The learning objectives for today's tutorial is to use balanced equations to calculate reacting masses. Now, the equipment that you require for today's tutorial is a periodic table, a calculator, a ruler, a mini whiteboard if you have one, and pen. If not, a piece of paper and a pen is fine. Now, from our previous tutorials, we learned about massive Mr. Mole. Now, just to remind you, this is a mnemonic to help you to remember the equation that links mass, relative formula mass, and the number of moles. Now, this was a formula triangle that we covered in our previous tutorial. Massive Mr. Mole, and that translates into mass in grams divided by relative formula mass, or mass in grams divided by moles, or relative formula mass multiplied by moles. If you cover up any quantity within this table, for instance, if you were to decide to cover up mass, you would know that mass equals relative formula mass multiplied by moles. If you covered up relative formula mass would be mass divided by moles. Or if you covered up moles, then moles would be mass divided by relative formula mass. So this is a very helpful formula triangle to help you with these calculations in your chemistry lessons. Please don't forget that mass is measured in grams. So just a quick starter to help us recap on our previous tutorial, what I would like you to do is calculate the following. So I would like you to, number one, calculate the number of moles in 49 grams of sulfuric acid. Number two, the mass of 0.3 moles of calcium carbonate. And finally, the relative formula mass of 2.5 moles of a compound with mass 45 grams. Now, whilst you're working these out, I suggest that you pause this tutorial because I'm going to reveal the answers, and obviously I'd like you to have a go at them first. So if you could pause this now while you're working out your answers. Okay, so now that you've had a go at answering those questions for yourself, the answers for the first one should have been 0.5 moles. The answer for the second one should have been 30 grams. And then the answer for number three should have been 18. If you did not answer those correctly, then I would suggest you go back and you have a look at the earlier tutorials. Again, in a previous tutorial, we looked at balancing equations. I would suggest you use the tally method that I showed you previously to balance those equations. You've got 4 equations to balance there. What I would like you to do is have a go at them. Pause this tutorial whilst you're working out these. And then when you're prepared to mark your answers, then you can play this tutorial again. So if you pause your tutorial now. Right, okay, so the answers for the following are, right, if you didn't balance these equations correctly, I would suggest you go back and have another look at the tutorial on balancing equations, just to recap, because this is a very important skill that's required for this lesson. So what does a balanced equation actually tell us? When we look at this balanced equation, we can see, okay, there's hydrogen, there's chlorine, there's hydrogen chloride, but what does that actually mean? Well, it means that one hydrogen molecule, that's 2 hydrogen atoms joined together, reacts with one chlorine molecule, which again is 2 chlorine atoms joined together. to give you two, that large two, that coefficient at the front, means that you've got two hydrogen chloride molecules. Now, that balanced equation will also tell you that 1 mole of hydrogen molecules, because you haven't got a number in front of the hydrogen, then you presume it to be 1 mole. So 1 mole of hydrogen molecules will react with 1 mole of chlorine molecules, and again you can assume there's 1 because there's no number in front, to give you 2 moles of hydrogen chloride molecules, and the 2 moles is because you've got the coefficient 2 at the beginning there. So using your massive Mr. Mole triangle, how could we work out what mass of hydrogen and chlorine react together and how much hydrogen chloride is made? So the first thing that you would do is you put down your balanced equation. And then what you would do then is you would use your massive Mr. Mole triangle to try and fill in as much of this table as you can. So if we look at this one then, obviously you haven't got the masses here, so masses is empty, but you can work out the mass from the formula triangle. So the first row to do, and again you'll need your periodic table for this, is to work out what the relative formula masses are for hydrogen, chlorine, and hydrogen chloride. So now you can see that this is your molar ratio. So you can see you've got 1 mole of hydrogen, 1 mole of chlorine, 2 moles of hydrogen chloride. To work out the relative formula mass of a hydrogen molecule, each hydrogen has got a relative atomic mass of 1. You've got 2 of them here, so 2 times 1 equals 2. To work out the relative formula mass of chlorine, because each chlorine atom has got a relative atomic mass of 35.5 and you've got 2 of them, it's 2 times 35.5, which is 71. And to work out the relative formula mass of hydrogen chloride, then you know that it's going to be 1, because you've got 1 hydrogen here, plus 35.5 equals 36.5. Just to point out that when you work out the relative formula mass, you don't include any of the large numbers, the coefficients. You do use the smaller numbers, the subscript letters, like the little 2 here, but you never use the large numbers at the front to work out the relative formula mass. That's to do with the number of moles, as we said on the previous slide. So what you would do is you would use this data to work out moles. So obviously we know that if you cover up moles here, it's mass divided by relative formula mass. So the mass here, okay, so if you were looking at the mass here is what you're trying to work out. So if you cover up mass, you can do relative formula mass times moles. So relative formula mass times moles. So 2 times 1 would give you 2. Again here, 71 times 1. So 71 times 1. And then finally, 36.5 times 2. And that's how you would work out the mass of each of those molecules. So if you've ever heard the expression, you can't compare apples with pears, well, similarly, you can't compare moles to masses either. So the best way to complete, okay, these sort of questions I find is to use a table. That way you separate out all the quantities, all the data that you're dealing with, and there's no confusion when you come to input your data into your formula triangles. So this is my quick and easy table method. Now there are other ways of completing these, and if you use your revision guide or your textbook, they will show alternative methods to completing these questions, but I find this is so much easier and quicker. So first of all, okay, make sure you learn this table. Okay, and when you attempt questions like this, make sure that you draw the table as shown below. So balanced equation will always go along the top, the molar ratio directly underneath it, because a balanced equation will enable you to work out the molar ratio. Then you've got the mass, you've got the MR or AR, depending on what the element is in the balanced equation or the compound is. And then what you've got there is you've got moles at the bottom. So you would always use your massive Mr. Mole formula triangle to attempt these questions. So that's the table that I would like you to learn off by heart, so you can use this to attempt all of these questions. So once you've drawn out the table, you write your balanced equation along the top, and then you work out your molar ratios, which are given by the coefficients when you've balanced your equation. Then you circle the columns that are included in your question, and you include any data that you're given. So when we go through the worked example on the next slide, this should be a lot easier for you to understand. But these are the rules that you should follow when you're attempting these questions. And then you include a question mark for what you're trying to calculate. Therefore, you don't lose sight of what you're actually trying to calculate. And then again, you use a massive Mr. Mole triangle to fill in the gaps. So these are the 5 stages for attempting these questions. And once you've had a go at the 2 examples, you're going to be doing some of your own independently. So what you've got here, this is an example of a question that you could get inside your exam. So you can see, okay, that it says, it's a calculating reacting masses example. We're going to go through a worked example. So it says, calculate the mass of iron sulfide produced when 5.6 grams of iron completely reacts with excess sulfur. So you can see that you've got your balanced equation there. I've already balanced that for you. You can see you've got 1 atom of iron, you've got 1 atom of iron here, you've got 1 atom of sulfur here, you've got 1 atom of sulfur here. So you can see that that equation is already balanced. The first thing that you do, as shown by the previous slide, is you draw your table as shown, and then stage number 2 is that you then include your balanced equation in the top row, and then the molar ratio in the second row. So you can see, okay, the molar ratio would go down below. Now, just going to go back to that question here. You can see sometimes it's really important to actually circle in your question what you're trying to find out. So you can see here that we're calculating the mass of iron sulfide. That's the mass you're trying to calculate when 5.6 grams of iron reacts completely with excess sulfur. So what we're going to do now is we're going to complete our table to enable us to find this answer. So these are the 2 columns that you're actually interested in. You don't have to worry about this column because no data has been given on that in that column. And if you have the molar ratios, you really don't have to involve this column. So the first thing, okay, you can see that 1 iron reacts with 1 sulfur to give you 1 iron sulfide molecule, okay? So they're your molar ratios. Now in the question, you're told that 5.6 grams of iron is going to react completely with excess sulfur. So sulfur's in excess, okay? You're not going to be given a mass for that. And then you can see that you're trying to find out the mass of iron sulfide. So the next thing that you do is you work out what the MR or the AR, that's the relative formula mass or relative atomic mass of iron and iron sulfide are. Now, because this is just a single iron, atom of iron, that's actually relative atomic mass. So you would get that directly from the periodic table, and it's 56. For this one, that's going to be relative formula mass. Now, to work that one out, you would do the calculation 56 plus 32 equals 88. Now, where did I get 56 and 32 from? Well, if you go to the periodic table, 56 is the relative atomic mass of iron, 32 is the relative atomic mass of sulfur. So 56 plus 32 would give you 88. Now, what you do now is you use this data, okay, to work out the number of moles. Now, you've got your massive Mr. Mole, okay, formula triangle there. So you know that from looking at this, this is what you're trying to work out in this first instance. You're trying to work out moles. So to work out moles at the bottom there, you would do mass divided by relative formula mass, MR. Because you're trying to find out moles, you would cover up moles. So again, that's mass divided by relative formula mass. Now, your mass here is 5.6. Your relative formula mass is 56. So if you did 5.6 divided by 56, you would have 0.1 moles. Now, this is where the molar ratio comes into play. You can see that 1 mole of iron gives rise to 1 mole of iron sulfide. So in this instance, you've got 0.1 moles of iron. So therefore, you would have 0.1 moles of iron sulfide because you've got a 1-to-1 molar ratio. So if that's 0.1, then it will be 1-to-1 again. So 0.1 to 0.1. So now, this is how you go on to find the mass of iron sulfide produced. So you now have your relative formula mass. You also have your number of moles. So what you would do is you would do relative formula mass of 88 multiplied by the number of moles, which is 0.1, and that will give you your mass of 8.8 grams. Now again, don't forget to include your unit in the exam, especially if they haven't provided it for you. You don't want to lose any marks. Remember, mass is measured in grams. That's 8.8 grams. So that's our first worked example. Right, okay, our second worked example then. This one's slightly more complicated, but again, you follow exactly the same pattern. So again, it says calculate the mass of chlorine gas, Cl2, needed to react with 100 grams of sodium hydroxide to convert it all to bleach. So there, that's your balanced equation. Again, I've provided the balanced equation for you to help you. Obviously, double check that you're happy it's balanced. You can see that you've got 2 sodiums here, 2, you've got the coefficient 2. You've got 1 sodium here, 1 sodium here, that's 2. You've got 2 times oxygen here. You've got 1 oxygen here, 1 oxygen there, so you've got 2. You've got 2 times the hydrogen here. And again, you've got 2 times hydrogen there. You've got 2 chlorine there. You've got a chlorine there and a chlorine there, so 2 in total. So we can see straight away that is a balanced equation. So the first thing you would do, okay, is you would draw your table, and then you would look at what you're actually trying to find out. So it's asking you to calculate the mass of chlorine gas, your mass of chlorine gas needed to react with 100 grams of sodium hydroxide. Now, even though I teach the subject and I've attempted hundreds of these sort of questions in the past, I still am in the habit of circling like the different parts of my question to label what I'm actually trying to find out and the data that I'm given. That way there's no confusion when you complete your table. So the first thing that you should do is that you should write your balanced equation, and then using your balanced equation you can write the molar ratio. Now if we look at this one, you can see because that's got the coefficient 2 at the start, then obviously that's going to have 2 moles. There's no coefficient at the start of that one or that one or that one or even that one, so therefore they're all 1 mole of each. So looking at that, you've got 2 to 1 to 1 to 1 to 1. So what information have we been given then? So we've been given information regarding chlorine. Chlorine's what we're actually trying to work out. So we're trying to work out the mass of chlorine. So that's mentioned in the initial question. And we're given data on sodium hydroxide. So we're not actually interested in this part, okay, of the equation at all. So we can ignore this. So what information are we given? Well, we're told to calculate chlorine, the mass of chlorine, okay, that's required to react with 100 grams of sodium hydroxide. So the next step, okay, would be to use the massive Mr. Mole triangle to fill in all of the gaps. So the next step would be to work out the MR. So we know that the MR of sodium hydroxide, sodium has a relative atomic mass of 23. We take that from the periodic table. Oxygen, 16, and hydrogen, 1. If you add 23, 16, and 1 together, you have a relative formula mass of 40. If we do the same now for chlorine, you can see that a chlorine molecule is composed of 2 chlorine atoms. So each chlorine atom has got a relative atomic mass given in the periodic table of 35.5 and 35.5. If you add those two together, then you have a relative formula mass of 71. So our next stage is to work out the moles of sodium hydroxide. So to do that, we use our massive Mr. Moles formula triangle, and you can see that your mass of 100 grams divided by your relative formula mass of 40 gives you 2.5 moles. So you've got 2.5 moles. 100 divided by 40 is 2.5 moles. Now, as you can see, you've got a 2-to-1 ratio, molar ratio here. So if you've got 2.5 moles, then you're going to have half the number of moles here. So that's why that's 1.25, because 1.25 to 2.5 is a ratio of 1 to 2. Okay, 2.5 divided by 2 is 1.25. So you can see that the molar ratios are equivalent. So if you now know that you've got moles, 1.25 moles of chlorine, so that's your 1.25 moles of chlorine, and you know that your relative formula mass of chlorine is 71, then you can do 1.25 times 71 to calculate your mass. So 1.25 times 71 gives you a mass of 88.75 grams. And again, remember that mass is measured in grams. So what I would like you to do is I would like you to download the question sheet that looks like this. What I would like you to do, if you're happy to do this without using the table, okay, then for these questions 2, 3, 4, and 5, okay, feel free to go ahead and do it without the triangle, without the table even. But for question 1, I would like you to use a table. If you are still getting to grips with this method, then obviously you can use a table to answer questions 2, 3, 4, and 5. And when I provide feedback afterwards to you when we do our green pen marking, I will actually provide the completed tables for you. So if you've struggled with any of these, okay, then obviously you can have a look at the tables and compare them with your own working out. So you will probably need about 15 minutes to complete these 5 questions. So I'm going to ask you to pause the tutorial now. And what I'm going to do is I'm going to allow you some time to complete those questions. Once you've completed those questions, then you can resume the tutorial. Right, okay, now it's time to green pen mark our work. So what I'm going to ask you to do is take a green pen, and then what I would like you to do is green pen your work. Now obviously, under normal circumstances, I would normally ask you to swap papers with your neighbour and to peer assess. But obviously, at the moment, because this is a Zoom and you're working independently, I'd like you to self-assess your answers. So to make it a little bit clearer, what I'm going to do is I'm going to increase the size of these answers to enable you to see them much more clearly. So if I scroll down, I'm going to give some time. I'm going to scroll down very, very slowly through these to enable you to actually mark your answers. So you can see that I've used the table method throughout, okay? Obviously, as long as you come to the answer of 2.4 grams for this first answer here, okay, it would be 2.4 grams of carbon would be needed to make 8.8 grams of carbon dioxide. Now, I will post this answer sheet along with my tutorial. So if you feel that you're not able to keep up whilst we're green pen marking this work, you can go back and you can have a look at it again. Right, for the second question, you were asked to write a balanced equation for the reaction between, well, the reaction where calcium carbonate decomposes, firmly decomposes to give calcium oxide and carbon dioxide, and to write a balanced equation. Well, as you can see there, that equation there is balanced. You didn't have to input any coefficients for that equation to balance. And then you were asked to calculate the mass of calcium oxide needed to make 560 grams of calcium oxide. Again, I've used the table method to complete that answer. And the mass of calcium carbonate required to make 560 grams of calcium oxide, I calculated to be 1,000 grams or 1 kilogram. Okay, so again, if you've had difficulty in obtaining that answer, then I would like you to pause this tutorial and then have a look at my green pen marking. Question 3 was very, very similar, slightly more difficult. You were looking at copper carbonate and how it decomposes to give copper oxide and carbon dioxide. Again, you were asked to produce a balanced equation for the reaction. You didn't have to insert any coefficients. It's balanced as it stands. What mass of copper carbonate is needed to produce 8 grams of copper oxide? So you were given 8 grams of copper oxide. If you are to carry out the tally method, the table method even, you should obtain 12.35 grams of copper carbonate. So 12.35 grams of copper carbonate are needed to produce 8 grams of copper oxide when it decomposes. Question 4, again, we were looking at thermal decomposition. So calcium carbonate will thermally decompose to produce calcium oxide and carbon dioxide. How much calcium oxide is produced when you heat 25 grams of calcium carbonate? Well, if you have 25 grams of calcium carbonate, you would end up with 14 grams of calcium oxide. Again, if you're struggling to answer this question, go back, look at the PowerPoint, go through the worked examples, and then look at the table to see where you might have gone wrong. And then the final question, what mass of water is produced by completely burning 15 grams of butane? So you can see that you have 15 grams of butane, you're trying to work out what mass of water is produced, and if you complete the table, you can see that 23.31 grams of water are produced. So this is an example of a combustion, okay, because you can see the fuel is burning in oxygen to produce carbon dioxide and water. So hopefully from the tutorial and the time that you've spent practicing these exam style questions and green pen marking these questions, you should be very confident, I'm hoping, in completing this sort of question that could appear in your exam. So what we're going to do, okay, I would like you to send me an email, okay, and in the email I would like you to send me one of the following. So if we just have a look, obviously we're going to have to adjust how we would normally work. So what I would like you to do is rather than handing your book in and putting them into separate piles, what I would like you to do is I would like you to email me one of the following icons, little emojis. So if you were really confident and that you answered most of these questions correctly, okay, so when you green pen marked your work and you answered most questions correctly, can you send me this emoji here, so the smiley face? If you found it was okay, but you might need some more practice when you did the independent task, you completed half of the questions correctly, can you email me this sort of mediocre face emoji? And then finally, if you're finding this really, really difficult and when you did the practice questions, there was very few that you were able to answer correctly, and you're still really struggling to understand this. Even when you go back and you go over the PowerPoint and you use the worked examples again to answer the independent task sheet, then can you send me the unhappy face, please? So obviously I can provide you with some more feedback and a little bit more support with these questions. Right, keep well, guys, and I will send you another tutorial soon. Take care. Bye-bye.